Welcome back to Backspace Academy. In this lecture on Simple Queue Service, or SQS for short, we'll go through and explain exactly what the SQS service is. It's a service for the queuing of messages and how we can use that to decouple our processes. We'll look at the queue types and we'll also look at the life cycle of a message as it passes through the SQS process. We'll look at dead letter queues. What do we do with messages that cannot be processed? We'll look at delay queues and message timers, and we'll also look at the process of long polling. SQS, it is a queue for storing messages, and it acts as a buffer of data for processing service. SQS can smooth out the peak demand. Up to 10 attributes or name and values can be added to a message additional to the message body, and the message size can be set from 1K to 256K. So just looking at the diagram there, we have messages coming in. So those messages will have peaks and troughs of demand. There'll be more coming in at one stage, and then there'll be gaps where there won't be so much. So between those peaks and troughs, the instance needs to cope with that. And we don't want the instance to be taken out by too much of a demand. So we allow those messages to build up in our SQS queue. And our instance will process those messages one by one. And it will, every time it finishes a message, it will go back and grab another one by polling the queue. And then it just keeps going until the queue is completed. SQS, it allows us to decouple our processes. So it allows us to cope with those peaks and troughs. But one thing we need to understand is that if the average demand exceeds our processing capacity, so over time, if those peaks and troughs still average out to be more than what our instance can cope with, then that queue will grow indefinitely and it will continue to grow until such point in time that the SQS service can't handle it anymore. So SQS, it can provide CloudWatch metrics that can be used with auto scaling. And that's a very important thing because that will allow us to introduce elasticity that is linked to the size of our SQS queue. And so that can also allow us to have upper and lower set points so that when our queue gets hit by a large amount of demand and it grows to a significant size, that will trigger a CloudWatch metric that will then alert our auto scaling group to add more instances. And with our lower set point, when that is reached, it will do the same thing, but in reverse. And the auto scaling group will start to terminate instances and reduce our capacity to save costs. There are two different types of queue types. There used to be in the past only the standard queue, but now we have a FIFO or first in, first out queue. So standard queue is the default queue type, and it provides nearly unlimited number of transactions per second. So if you need speed, the standard queue is the way to go. It guarantees that a message is delivered at least once, although you need to be aware that although rarely, duplicates can occur. And so your application needs to be aware of that and have checks and balances in place in case a message is processed twice. And it does best effort ordering. So although most of the time the messages will come in the order that they're received, it's not always the case. So then we look at first in, first out queue type. Now that complements the standard type and it's limited to 300 transactions per second. So it is slower than a standard queue type, but it provides first in, first out delivery of our messages, and it provides exactly once processing. One thing to be aware of, it's currently not available in all regions, so you need to check your region to make sure that FIFO queues are available. It's very important to understand the life cycle of a message as it passes through the SQS service so that our application can work properly. So the first part of the message lifecycle is that the message is received by the SQS queue. Then the message will be received by the processing server. When the message is received by the processing server, the visibility timeout period starts. So at that point, it's not visible to, the message is not visible to other instances that may be polling that SQS queue. So once a message is processed by the processing server sends a message delete request back to the SQS service. At that point, the visibility timeout period ends. So the visibility timeout specifies the time which the message is invisible in the queue and has not been deleted. And then once it has been processed and deleted, then the visibility timeout period ends. So if a message has not been deleted by the visibility timeout period, the message then becomes visible and can be received again by a processing server. So that's another thing that you need to take in consideration with your application, making sure that you can process messages within that visibility timeout period. Dead letter queues can be used as a target for messages that cannot be processed successfully. So that allows us to remove these messages from our queue and at the same time not lose those messages, and allows them to be analysed or reprocessed at a later time. You need to remember that dead letter queues must be in the same region and from the same account as the original queue. Delay queues and message timers allow for timing changes to be made to a message's life cycle. So delay queues, they postpone the delivery of new messages, and the message is not visible when it is first added to the queue for a defined period of time. So that defined period of time is set with delay seconds parameter with the create queue or set queue attributes command for the existing queue. You need to remember that there is a 120,000 limit for the number of in-flight messages per queue. So make sure that if you implement a delay queue, that limit is not going to be exceeded. We also have message timers, and they implement an initial invisibility period for an individual message. And they can be created using the console or with the delay seconds parameter of the send message command. We need to understand the different types of polling. So when our instance has completed its process and it is ready to receive another message for processing, it will poll the SQS service. And there are two ways for an instance to poll the SQS service for new messages. And we have short polling and long polling. So short polling is very simple. It just sends, the SQS service simply sends a response back immediately whether or not a message is in the queue. So that obviously will require the instance to regularly keep polling the SQS service until such point in time as a message is available. The other option we have available is long polling, and that will return a response to the instance, and it will wait until a message is available before it does that. So it will wait until a message is available in the queue before sending a response. So that significantly reduces the workload on our instance. Our instance is no longer sending all of these messages or these requests to the SQS service. It will send one request, and then on an asynchronous basis, it will have that sent back when there is a message available. So it reduces the number of empty responses when there are no messages available to return. So we set the wait time seconds parameter in the receive message call, or the receive message wait time seconds in the create queue or set attributes call. And that is a parameter between 1 and 20 seconds. So that brings us to the end of our lecture on SQS. I'll see you in the next lecture.